And welcome to the final video on Surds. In this lesson we're going to be looking at rationalising the denominator of a fraction involving surds. So very common exam style question, and it's really good that we get to grips with this. So without further ado, let's jump right in. So first thing to remember is that a surd is an irrational number. So in the fraction 5 over root 2, we have an irrational denominator of this fraction. So when we're asked to rationalise the denominator, we have to turn this root 2 from an irrational number to a rational number. So how do we rationalise it? This is the purpose of this video. So let's take an example question. Let's take 5 over root 2, and we have to express that fraction with a rational denominator. So before we do this, let me ask you a question. If I was to multiply that fraction by 1, we're just going to get the fraction back, yes? We're going to get 5 over root 2. Similarly, we could do 5 over root 2 multiplied by 1 over 1, which is the same thing. It's multiplying it by 1. I could even say this. I could multiply the fraction by 2 over 2, because 2 divided by 2 is just 1. I could even go any number divided by itself is 1, so 32 over 32, if I multiply that by this fraction, I'm going to get the fraction back. So the question is, can I select a fraction which equals 1 to rationalise the denominator? Well, let's take this for an example. How about if we multiply top and bottom of the fraction by the surd? So if I multiply the top by root 2 and I multiply the bottom by root 2. This is the same thing as multiplying it by 1, yeah? Because we've already agreed that this fraction will equal 1, so we're going to get the equivalent fraction. So let's do this. So at the top we're going to have 5 root 2, and at the bottom we're going to have 2 root 2. And this is the key here. Because we've got root 2 times root 2, the multiplication law says that we're going to have root 4, so it's 2 times 2, square root of that. So root 4 is 2. So what we're going to be left with is 5 root 2 over 2. And that is the exact same answer as this, so the fraction, except now we've converted it as a ratio with a surd at the top and a rational number for the denominator. So let's have another go. Express 3 over root 5 as a fraction with a rational denominator. So we've got 3 root 5, and we're going to multiply it by root 5 over root 5. Because now what we have is we have 3 root 5 at the top, these root 5s at the bottom, they become square root of 25, which is 5. So 3 root 5 over 3. And we've rationalised the denominator. And this is the technique that we use. So let's have another go. 16 over root 7. Let's express this as a fraction with a rational denominator. We're going to multiply top and bottom by root 7. And what we get is 16 root 7 over 7. Let's have another one. 24 over root 6. So we've got 24 over root 6. We're going to multiply top and bottom by the surd. And what we're left with is 24 root 6 over 6, just like that. And we can actually cancel out the 6, so 24 divided by 6 would be 4 root 6. So this is the answer in its more simple form. Okay, so just to recap on that, to express a fraction with a surd in the denominator as a fraction with a rational denominator, we need to rationalise the denominator. So this is the term that comes up. And to do this, we multiply the numerator and the denominator by the surd. We simplify if necessary, and that gives us the answer. Okay, so have fun with that one.